swear they put the bike lanes wherever the most potholes are. Whoa! You son of a... Hello Internet, and welcome to the first Q&A of 2020. Now, I wanted to do like a year-end wrap-up in addition to like the Q&A and all that stuff, but I just don't have time right now. I'm sorry. I got quite behind on a lot of things. Not only am I playing catch-up with like this channel stuff, but also everything in life and all the other stuff that I do for, you know, money to keep lights on and things like that. So anyhow, this is mostly going to focus on the comments and questions from the last video because there were a ton of them, and I went back in the comments and I answered some, but when I had all that wacky stuff, I went into all of my internet accounts and turned on like two-factor authentication for everything didn't have it, including like, you know, Google accounts and YouTube and all that stuff. So I had inadvertently that signed me out of YouTube on my phone, so I wasn't getting notifications of questions. So like I posted that video on the tubing and the couplings and didn't get any, you know, notifications of questions, and I was like, oh, I guess nobody really cared about that. That's fine. But then next morning when I got up and looked at my computer, it was like 8 zillion questions, and, you know, a fight had broken out in the comments, and I was like, whoa. Let me handle the, I know I'm late, as, you know, the moderator of the threads underneath my videos, late on the trying to peacekeep and everything. Apparently I pissed in somebody's cornflakes, but an individual took umbrage with some of my measurement methodology, which is odd because I didn't show measurement methodology. I cut that section out. I just had a little fast-forwarded section of me measuring the thickness of the tubing in various spots that I blurred out after like 3 seconds and then did a voiceover. I understand where they, actually, because there were thumbs up underneath the comment, are coming from with like measurements. You have to make sure that you're proper on your measurements. The thing is, if you don't have a standard that you're measuring to, then it just becomes like an 8th grade, you know, pissing contest between like, I think my way is better type of a deal. So here's the thing. And this is true to the point where it is a cliche, and any professional who's done like for realsies work for people who have to work to actual standards should know this. There is only one answer to how you, well, do anything, but we're talking about measurements here. This could be spreadsheets, this could be anything in the workforce. So let's do a little role play here. Let's pretend that you are applying for a job and I am a naughty nurse. No, wrong kind of role play. Let's say you are applying for a job and I am a hiring manager. So, Mrs. Smith, what is the correct way to perform a measurement? There is only one correct answer to that, and if I win you a 6-figure salary with this question, feel free to contribute to my the support links in my video description below. I'm so bad at commerce and asking for money and stuff. Correct answer is to look them in the eye and say the proper way to perform a measurement is to the specifications of the paying customer. That's it. Like, end of discussion, period. So if you're doing like a job to mil spec, the answer is however that particular spec dictates. If you're doing it to ISO, you do it to ISO. If you're doing it to DIN, JIS, whatever. And there are thousands, tens of thousands of different standards. And if you have ever done a real job for real people in a real world, what you do is they tell you what the spec is, you go pay for those spec sheets, they're like $50 a piece, and then under the spec sheet they have all the different like methods. So you go and then you pay to download the methods sheets, and then you follow that method. So the standard tells you what, and the methods tell you how. So if you're like, you know, ISO 126-479.2 2014, you know, that type of deal, then it'll say diameter is measured according to method like D825 or, you know, whatever. And then you look at D825 and it says how to do it for that particular standard. So if there is not a particular standard that you're measuring to, well, then it just becomes a conversation of like, I think this is better, or I think this is better, or this is how the, you know, this industry standard or something like that. And yeah, I'm not interested in pissing contests, but as the update for the Capricorn tubing, I have been in contact with them back and forth, like after a dozen different exchanges, or a half a dozen different exchanges. I'm not quite sure they knew what I was asking, because I said, if you go to their website, and I checked this before that video, I went to the site first and I was looking for data sheets to download. All their data just goes to that one chart that I showed in the video several times. That does not anywhere on the site or on any of the secondary and tertiary information say what standards they are measured to. So you have to, ask them what standards they preferred to be measured to, so that I didn't do anything silly. And I followed up with this again after the video on another link, and they didn't know what I was talking about. So I said, okay, well, this is what I did, and I just showed them with standard calipers using like the methods anyone could use at home to measure this stuff. The known sealed good tubing I had from them, and then the supposed fakey stuff, fake question mark, counterfeit question mark stuff. And then when I sent that to the support link, the individual I was speaking to said, oh, yes, we are aware of this issue, and they're going to be following up with all of their... let me pull up the exact quote. What we're planning to do is gather details about authorized and authentic tube resellers and update them. If you want to know about official resellers and Amazon resellers... I can help you with the same. So yeah, so that it seems like they're just going to be cleaning house since there are so many fakies out these days. So it is a known and widely enough spread issue that, at least according to this individual, it's something that they're going to have to stop and take care of this year. But the point of the video was to try to, and what I was doing in the, one of the many different types of tests I was doing in a little compressed section, was to try to figure out ways that people can measure these at home just to tell if their stuff is the real deal or not. But until I get positive confirmation from the source about the methodology, I can't definitively say which way to measure it. I can just show you at the end of this video the A versus B. It's obvious to see if you have both of them sitting there, but not everyone has them both sitting there. So as soon as I hear back from them, then we'll know. Or if I don't hear back from them, we'll have to figure it out ourselves. Okay, first one. Evil Gaming, effing awesome videos made here. Have a sub. I definitely like the hydraulic coupler mod how to, and an order of fries, please. Yeah, so I will stick that at the end. And for everybody asking these questions, there's a video index always in the description. So you can go down and click on that. It'll take you to the section of the video you're interested in. So if you're one of the folks that asked about the couplers or asked about where the Bowden tubing came from, just take a peek down there, take a click, and it'll put you off. I'll try to put like affiliate links for certain things, but they might just be regular links, which means I don't get any money off of that. But whatevers. Let me see. Yeah, he was a Cat Lord 21. Do you have a reference with hydraulic coupling you use? Thanks. Yes, I'll put that to the end. Jaro says, good topic. I know it'd be about stretch and slop, just friction, maybe an AliExpress affiliate link for the black tubing. Yeah, somebody down further in the comments actually dug up where they were. I think they put it up there, and it's the same, I think, as the Black Triangle Labs tubing with the 1.9 millimeter inner diameter. So yeah, that I will put that at the end as well. Great analysis. Thanks for sharing. All right, Carios 1014 says, oops, hopefully you can read all this. Thanks, Alex. Keep that technical detail coming. It's hard to tune for a system if you don't know how it works. Yeah, absolutely. Something that bugs me is that there's no feedback in the control system, which is the most important parameter. Which I believe is, I read that wrong, sorry, which I believe is probably the pressure at the nozzle, question marks. I'm trying to think of a way to achieve that. Maybe a servo motor with power or torque sensing for an extrusion drive. Yeah, that's something I've thought about a lot too. And I did get in the mail one of the MK42S servo systems, whatever, from AliExpress, and I'll see if there's a way I can hack the firmware to do something like that. But yeah, the problem is you might be able to do, you can do idealized math, like if you have pressure and diameter and that type of thing, you can assume throughput, but it's really tough to get. What you really want is the throughput. So you can assume the diameter of the nozzle, and you can assume from the pressure, and you can assume from all the other things, what kind of a flow you're getting, particularly if you have multiple sensors, so pressure and a sensor up before it's the feeder if you know what I'm talking about. And then you can just extrapolate what's coming out based on, those two. But yeah, I mean, pressure would be a big one, because really with like linear advance, we're estimating pressure, and with like retraction settings and speeds, like we're estimating, pressure and that sort of thing. Yeah, ideally that would be it. And I might touch on that in sometime in the future, hopefully. I wish it were in the past, because I've been wanting to do this for a long time. But when I do eventually do the official, probably like series on extrusion, I have to find a way to turn like a 3D printer nozzle into like, a ghetto DIY at home like rheometer for that, because I could easily go through and give you all the rheology of 3D printing, filament, melt flow. A lot of that is known from the injection molding industry for, decades now. And it's not tough for people to just take samples of thermoplastic, melt it down, and put it in a capillary rheometer and like see what some of the, the melt flow index and the viscosity is, and the non-Newtonian like curves. The problem is we don't have that. We have that like for raw materials and pellets and things like that. We don't usually have those specs for filament. And as a result, we don't have filament that's controlled for those specs. So that goes along with what you're asking. So you're like, well, it would be nice if we could do it with, pressure and this and that and the other thing. But that also depends on the geometry, the hot end, the speed you're printing at, the temperature you're printing at, and it gets very complicated very quickly. So yeah, the reason that I haven't just done the technical document, which is what I was going to do like a year ago when I started pre-recording that, was that it's really just spitting out a whole bunch of math and then saying like, onward, soldiers, go figure out a solution. And I would rather have some testing to go along with that. So this is just not me, talking math at you over and over again and having a lot of open-ended, statements without any solutions. Bernard Travers says, on their site, Capricorn lists authorized resellers. If anyone's looking to save a few bucks by buying elsewhere, I've got a bridge to sell you. I did buy from an authorized reseller. I was going to do, after I found this like little weirdness, I was going to get another sealed container from Capricorn and then buy samples from a bunch of different resellers and A/B them against the Capricorn tuber. So if you are a reseller who's doing shady stuff, bear in mind that I may have already done that by the time this video comes out. Or I may not do it at all. You don't know. Better stay on your toes. Has Michael Gamber says, has anyone mentioned this? Let me see if I can bring this up. This is a, hopefully I can see. Oh, I see what this is. This is a hotend aglet. Well, that's very interesting. I have not tried that. Maybe I'll give one a try. $13. Yeah, I'll give it a go. That does look interesting though. Yeah, here's the Geek in a Cave. For anyone interested, I reverse engineered the link back to the Black Eye Express Teflon tubing. Yes, that is, and it is very similar to the Triangle Lab stuff. Yeah, I posted underneath. Yeah, I do think that's the link, but I will dig out of my AliExpress history the actual link and then post that at the end of this video. Let me see. Oh, this is a long one. I'm not going to be able to fit this. I'll do a paragraph at a time. Thumper Forever, about pneumatic fittings. Playing with compressed air. I purchased hundreds of fittings from reputable manufacturers. Cool. And from Chinese resellers like eBay and AliExpress. Cool. All diameters, genders, blah, 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 blah. Chinese ones are very cheap, but I always got 10 to 20% of them not airtight. Yeah, that's the problem with a lot of those types of dealios, is that you'll get them cheap, but they're not certified to meet any specifications, so you can't use them if you're working on certified gear or gear that requires things to meet spec, particularly like mil spec or medical or something like that. But also, even if you're just using it for home, you have to sort them for like how good they are. So that's why I did mention in the video a little bit, like, of the fittings that I have, some of these were good, some of these were bad, and a lot of the Chinese ones that the bulk majority of them are from China, but like the regular blue ones that you would have to put the clips on, super sloppy. But some of the ones, the black ends, the through couplings, I think someone had I'll talk about this more in a little bit, like they were pretty good. And I think I accidentally cut that section out of the video, but I did have a section on those black couplings. Anyway, let's see. Barbs are poor quality and don't last very long when playing with them. Yeah, and playing with them, if you have a lot of retraction and advancing, particularly if you're printing like high speeds or something like that, because you're putting a lot more tension in the system. Well, compression in the system, which results in tension on the bowden tubing. Therefore, you have to buy 10, and 8 or 9 of them are usable at most. Yeah, absolutely. Let me see. Most Chinese pneumatic fittings have an internal hexagon, so they all could be tightened using an Allen wrench, but the tubing will not go in straight unless they're pre-drilled. Yeah, I think I mentioned this in another video. Like, a lot of times those couplings they're either off-centered or it's just not good for the tubing is going through, because these are pneumatic coupling. It's just meant for air to go through, not a solid. So I almost always have to, with the cheap ones, take a Dremel and drill it out and then clean up the hole and blow it with compressed air to make sure I don't, flush brass dust into my nozzle and that sort of thing. Better to get them from an industrial supplier or a 3D printing specialist. Yeah, I agree. And usually they're pretty cool too. If you get some that are goofy, they'll usually just say, we'll send you some good ones, or like send them back so we can check them out and we'll send you good ones. The best non-compressible fittings can be seen at 724, the ESD and Triangle Labs. Yeah, the ESD, like the blind fittings and things like that, they have the clip. They're pretty good. I do have them. Like, this wasn't supposed to be a comprehensive video on like the couplings and fittings and things like that. It was just about those weird ones, because I figured everybody else has covered the couplings to death. I mean, I can do a if you want a comparison on video of all the different couplings I can get, but I will have to order a bunch from various sources like overseas to get the overseas one. And see how they hold up. But yeah, these guys, hopefully you can see that on camera, from like E3D, that have the metal jaws inside and it clamps on the four. These are pretty good. And that's what she is talking about here. I reinforced, this is from Nitrum. I reinforced my own bowden with mesh cable and tubing, and then did a link and said I managed to lower the PA value as well as the retract a fair bit. Yeah, that's pretty interesting. I assume by PA you mean pressure advance, linear advance, etc., etc. Yeah, I thought that was pretty clever. What I had done, I don't know if this is. Hang on, let me see if it's here. Nah, I tossed that somewhere. I took the more rigid, like aquarium poly tubing, and stuck that, like sleeved that on top of the bowden tubing with like various types of glues inside, and then zip tied it. I didn't have a lot of luck with that because it's Teflon, so it doesn't stick very well, even after like, scuffing it and cutting it and things like that. But that's cool that you got that working out. I may try that a little bit. I did also look in other industries, like I went to the Swagelock website, Swagelock, whatever, that do that type of tubing, and looked at their stuff that's like sleeved and jacketed, and it has like compressionless type of tubing with like bowden sleeving on the inside and things like that. Just finding stuff that's has reasonable ends on it in the lengths, like if it has to be pre-cut in like the reasonable lengths to work with like a 3D printer, and happens to be all the same like dimensions and doesn't cost like $50 per tube is pretty rough. And it's like looking for a needle in a haystack, because a lot of that you can't just do like the Amazon search for it and bring up a bunch of things you can look at. You have to go to their website, type in specifically what you're looking for, and then like rifle through their catalog or like PDFs. And there's a lot of times not pictures, or you have to like at least know the family. Then you click on that, it brings you to the data sheets, and then you can see sometimes some pictures and dimensions and whatnot. Yeah, so if anybody thinks of a ready-made solution, although part of me thinks like Ultimaker or one of these bowden based printers that sells them for like $5,000 would have found something like that already if it were an issue. But then again, the answer for a lot of things in the 3D printing world is like use our provided profiles or print very slowly, that type of thing. And you're like, all right, well, I don't want to keep us mired in printing at 30, 40 millimeters a second. I'd like to multiply that exponentially. That would be nice. And we can't do that unless we figure this stuff out. But hey, whatever. I'm not the one that sells $5,000 printers. Let me see. Oh, Diego says, I noticed your bowden tubers are longer than they need to be. I would assume that longer means more friction, but also a higher bend radius. Have you tested the optimal length? And Miroslav, I'll scroll down so you can see it. Miroslav linked one of Chep's videos. Like, Chep just did a video on the effect of the Bowden tube length of the on the ender, and he found a range for his settings. His settings are for very slow printing. They're very good settings. So yeah, you can check out that video. The problem is once you start ramping up the speed and once you start ramping up the other things, if you're using like, you know, a high, we'll get to this when I start messing around with the hot end. You know, replace that with larger diameter stuff, or you're using different tubing that has that you have feed at a much different rate, and you get a lot more Bowden stretch. Like, that's all going to be contingent on like how much you are stretching your tubing and how quickly you're advancing and retracting and that sort of thing. So bear that in mind when you see Chep's video. Like, that's tuning for his profiles, which I said are good, you know, for as far as visuals are concerned, and like low printer speed. So yeah, you can use that as a reference. These tubing, they were longer than they had to be because I knew that I had to cut the ends off a little bit, like as I was doing testing, because like, you put it in, run a bunch of tests, and it mangles the ends, and I wanted to be able to, like, you know, cut a centimeter off of each of the ends and then, you know, retest them again with different couplings. But I did chop them evenly for each of the tests, and then I also needed them all an even length for doing like the stretch tests, and I figured, you know, 400 millimeters. I think, was it 400 that I used? And then I think I ended up using like 350 after that. Yeah, anyways. Can you tell me the exact model of hydraulic coupler? Yes, I will. Yes. Links to couplings would be nice. Yes. And you may get some money too. Mark McDonald, I was getting excited by the non-Newtonian liquid part, and then you just said bye. Yeah, I know, sorry. Now I need graphs of viscosity versus pressure with hysteresis of different filaments. Oh, how will I sleep until then? I did a comment underneath, and yeah, here's the thing, like, they would say if you're reading a white paper, like, the math on this subject is well known. You know, it's like rheology is not a mystery, like melt flow of thermoplastic is not a mystery. It's just melt flow of thermoplastic within the confines of the 3D printing system at those particular speeds and pressures, like, that's not known, as well as the geometry of the hot end and stuff like that. So it's one thing to use like MFI, melt flow index, or hot flow index for if none of you know what okay, let me back this up a little. If none of you know what I'm talking about, look up rheology on Wikipedia, then come back. I'll wait. Okay, there we go. So anyhow, yeah, so if you're talking about like melt flow index in like a traditional rheometer machine or something like that, that's one thing. But another thing that needs to be studied, and I'm going to add more things that'll keep you up at night, like me, what happens after you have taken those pellets, melted them down, and then extruded them out into, you know, water, however it is you're making the filament, dried them, coiled them, then uncoiled them and reprinted at a particular temperature and under particular conditions and that sort of thing, with or without the bed, like all that stuff. So you get to these points where you're like, there's a whole lot of variables that need to be done that we actually don't have the math for. A comparison of pneumatic tubing with clip or zip tie end teeth versus hydraulic fitting with either the real Capricorn or the black tubing. Interested in the differences substantial enough to go hydraulic. Again, thanks for the real eye opener. I believe I do. I did. If I didn't, I think I put that in the video, but if I didn't, I will go back and dig through the footage and stick that back up. Hey, it's me from the future. So I don't know if I put that in there or not. So here it is. This is the real ass Capricorn tubing with the clippage on. You can see there's a little bit of stringing here. I mean, it's pretty good. And remember, this is 2 millimeters of retraction. And here it is, the exact same file, but printed with the hydraulic cupping. Patrick Wegler says, and I was thinking about remote direct extruders to circumvent my retraction issues. I have not messed much with at all, actually, with remote direct extruders. I've thought about it like on and off. So if people think it looks promising, I'll do it. But Oh, if you don't know what remote direct extruders are, that means like you're driving it directly, as in not pushing the filament through bowden tubing. So you have the feeder on the hot end like you would with a direct drive extruder, but the motor is remote, and then you have like a power shaft. So the thing is are pretty expensive. So if you're interested in that, I can check it out maybe for something at a later date. But anyways. Aubrey Kuhn, I don't know, a 3D printer, so maybe it's me speaking from ignorance, but would bicycle, oh yeah, this was the bicycle cable question. I imagine you need different couplings and blah, blah, blah. So yes, Aubrey and other people, I have worked in and out of bike shops for years, many years. Anyway, and been service manager at a couple different shops and head mechanic at a couple different shops. So yes, very familiar with bicycle gear. Brake cable is compressionless, but they don't. It's only in one direction because it's a spiral wind. So I did think about spiral wound, at least external casing, and they do have different types of casing that do have PTFE sleeving in there. It's not hardened usually, but it is optimized for lubricity, slipperiness. And then there's also SIS casing that is meant for several different internal diameters. I think off the top of my head, it's like they had like one, I don't know. I actually don't know what's popular now. I think like 1.6 and 2.0. And I didn't have any of the thin, like 4 millimeter external diameter SIS casing that uses the stupid plastic ends. I didn't have any of that right here. And, but I have thought about trying that in the future. That is in the, like looking for solutions with like, you know, the swage lock stuff and repurposing from other industries. So yeah, I have been thinking about that, like the SIS shift cable housing and the different brake housing and things like that. I would like to know the size of the hydraulic coupling. This is Sidewinder 85. Oh yeah, this was a good one. I want to know the size of the hydraulic coupling in the video. I'll put that at the end. I'm sure I can figure it out from the flashes, blah, blah, blah. I used the blacktop pneumatic coupler and has much better grip than the blues. Do I have one of those right here? But some of these through couplings are actually really good for some reason. And there's the white tops, and then actually I think these were the Capricorn ones. I'm not positive. The ones that came with the Capricorn tubing. Then the blue tops and the black tops or whatever. The black tops hold really well, like the one that comes stock on the hot end of the ender, or at least it came stock with the hot end of mine. That's the original coupler. I haven't had any problems with it slipping or anything like that. Plus, when the tubing goes into the hot end, that holds it pretty well and it doesn't slip. Sidewinder says he made his own feeder, cold end, hot end type deal for it, and he uses these. I wanted to try that, but wanted to squeeze that video out quickly. This bucket of stuff that represents the extruder from the what's the big brother, CR10 or whatever. This is the dual gear upgrade thing. This uses the 10 millimeter on this side, the through couplings. So I did want to test this. Like I said, I didn't have time, but I do have the cheapy dual pinion, whatever they call it, gear feeder upgrade thing for that uses the through coupling. So yeah, sorry I didn't get to test that out. How did he reply? Yeah, I've designed a belt-driven 3.75 to 1 ratio 40-tooth pinion gear. Bought as well as a hub gear, but I like the pinion, scrubbing, blah, 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 blah. So use a black top coupler. Okay. Yeah, that's cool. That is cool. Yeah, I'll have to take a look. I have my, that live stream printer has a, I think it probably uses the same feeder gear that you did, the 40-tooth, like hardened ones, the like robot dig style, like those grip like a mofo. And it is also a belted extruder. I don't remember the ratio. I think it was lower than it was like 2.25 or 2.5 to 1 or something, just because of the motor that I used on there. But yeah, I dig direct belted extruders, and I'll have to do a thing on that. Tyson O'Brien says, for the extruder, I usually back off the coupling a half turn, seat the tubing, and then type. Yeah, that's how I did all the different changes. On the hot end, what he's saying is seat the tubing down into the extruder to the point where the, well, I can show you this. Like, tighten this down the whole way, back it off a little, seat the stuff, and then once you crank this down past the area that there's slop, it grabs and will shove it down further. Just don't do it too much so that you're smooshing the end of the tubing down into the extruder, because then you can get jams. So yeah, just like half a turn or so is pretty good. All right, I will stop there. How much have I been talking? I've been talking for probably an hour. Usually I have the spidey sense of about like 55 minutes is where I start to get, and then I'll try cutting this down to under 45, hopefully under half an hour, but we'll see, because I have to tack the stuff on at the end. So, oh God, this might end up being an hour long. Oh God. Anyway, we will try to get a video out soon. So maybe I will do a shorter video on one part of cooling, and then probably something fun but unrelated. So we'll see. We'll see what I can pull up. I have like 20 partially done videos that have been accumulating over the last 6 months or so. I'll have to put something up. So anyway, until then, peace. All right, here's the stuff I promised, and I will put links in the video description. Hopefully they're still current. This was the black tubing that y'all asked for, so the 1.9 millimeter inner diameter, 4 millimeter stuff. This is what it looked like on a store. Somebody, like I said, reverse engineered that link already. These were the compression fittings. So yeah, this was, make sure to look at the section where I show you what I had to do to make these work, because they're not exactly perfect. I was looking for cheap, just as a proof of concept, not like a workable final thing. And these were the hydraulic fittings that I got. They're just called compression fittings. I think the ones that I got were labeled for use as like oil fittings or something like that, but they're sold as like, you know, water or air or all kinds of different stuff. These were, or this was the bag that it came in. I also got other ones from eBay, which were essentially the same thing. Originally, I wanted to try these better quality looking like bike hydraulic brake parts, but they didn't have any at the time when I wanted to order them, and like the Shimano stuff was super expensive. Let me show you some of the videos it took to send screenshots over to Capricorn and other folks. These were not for any definitive testing. This was just to show the difference between the stuff that I got out of the you know, sealed branded Capricorn package and the stuff that was not performing up to snuff that triggered this whole thing. So as somebody had suggested in the comments, I had taken those drill bits that were, you know, you saw lying on the table, and just found one that kind of barely fit in the real deal, and figured I'd take that, stick it in the not real deal, and you can see how much it's knocking around. I mean, that's kind of an extreme amount of play there. Another thing I did in the parts that I didn't include, because I'm still waiting to hear back and get some confirmation on some things, was to kind of validate the methodology or qualify the methodology, was take a length of the real stuff and the fake stuff, chop it up into little pieces, throw it in a thing, mix them all up, and then use the measurement methods that I had shown to positively identify the real E versus the fake E, and then show you that under a microscope. Not that, like, you really have to do that, but, you know, didn't end up including that section at all, because did not hear back in a timely manner from everybody. Oh yeah, and I also have all of these tension videos in one continuous shot, because I know how foil hat people get sometimes. Another thing I also did was take a tapered mandrel like this, or an insertion gauge, whatever you have on hand. Maybe you have a piercing shop near you. You can stick that in there, see how far it goes on the one, and then mark it off with a mechanical pencil and stick it in the other one. So obviously that'll show you how much of a difference you have between the two. Again, this isn't for an instruction. This was just what I sent to Capricorn. Here's also, for just your edification, microscope pics of, this was the black tubing, the black AliExpress tubing. This was a cross section of just the regular old like white PTFE tubing. You can see how like magnum that inner diameter looks compared to like the Capricorn tubing right here, which is like the genuine stuff out of the package. I mean, it's only a difference of like, you know, 0.1 or 0.15 millimeters, but it looks like the world when you put it under a freaking microscope. All right, now quickly I will show you how I made the hydraulic couplings compatible with the filament. Basically, it just, well, I'll show you. And then I'm done with this for now, because I still have ancient stuff to do, like all the oscilloscope videos and the trinamic reviews and the torque tests and the nighttime job as a vigilante fighting crime. I mean, what? And the water cooling videos and the Arduino sensor stuff. Actually did record and narrate this, but I cut it out, so now I'm going to re-narrate with the original crappy drawing time. So this is a very poorly drawn version of the barb that goes inside. Now the problem is the internal diameter of this barb isn't big enough for the filament, and it's going to push out the bowden tubing so that it's too big to get the olive over top of. And again, this was just an experiment about taking slop out of the couplings so that I could get other measurements, so don't think that I'm saying this is like the ultimate coupling or anything like that. I'm just showing you what I did for the experiment. Anyhow, this was the video of the 4 different parts of it. So what I ended up having to do was shave down the sides of the internal barb so that it sat flush inside the coupling, and I also had to shave down the sides of the bowden tube, like slim out the bowden tubing for what had been shoved out by that compression fitting barb or whatever you want to call it. So again, you know, not an elegant solution by any stretch of the imagination, very DIY, but that's like everything on this channel basically. And it was really just a proof of concept type of a deal. So I'm sure there are ready-made solutions out there, not necessarily for this industry, but at least stuff that would be cleaner to work with and better dimensions. I'll keep an eye out. I don't know if I'm going to actively look for that, but if there's enough interest in this, I guess I can poke around like the bicycle and hydraulic and pneumatic and oil fittings industries and see what happens. Now, I didn't compress the bejeepers out of this like you would if this were pumping oil or water or something like that. I just wanted to do it enough that it would start to crush the olive a little bit and make both of the edges dig into the sides of the tubing. So obviously that will vary. And when you get it down to a reasonable tightness and, you know, it passes the pull test type of a deal. And then, since we squashed everything in a little bit, as in the barb, I went ahead with like a 1.9 millimeter bit on a Dremel and just reamed that out so that the filament will fit through there fine. It'll end up being bigger than 1.9 because there's going to be a little play since a Dremel's not exactly a super precision instrument. But anyways, that should be enough. And then take a little piece of filament and push it in there, in and out of there at every angle you can around the edge of the coupling to make sure it doesn't catch up on anything. Also, make sure you don't get a whole bunch of brass dust in there. It's going to wash into your nozzle and clog you up. Like I said, not the most elegant solution, but if you're interested in perhaps doing it sometime in the future, like I said, I will leave this on my printer and use it. So if there's any long-term weird effects, then I'll let you all know in later videos. So subscribe to find out how my stuff fails. So anyway, that's all for now. Thank you very much. Hopefully I answered all your questions. If you have any other ones, leave them in the video description below, and I'll try to mention them in a future video. So yeah, that's all. Seriously, go away.